All right, well, it's great to be with you today. I love doing these things. I don't like traveling, but I like getting here and sharing God's Word and how science confirms what the Bible teaches. We live in an age where people have made the claim, especially secularists have made the claim, that you can't trust the Bible because science has somehow disproved it. And one of the areas where that is very prominent is in the area of astronomy. And I got to tell you, you'll even find this in the textbooks that students use at most public schools that are government funded. People like to think public schools are neutral, but for the most part, there's an anti-God agenda there. And I don't mean to offend anyone. Those of you that are maybe teachers in public schools and are Christians, praise God, you're a missionary in a system that I consider to be very pagan, is what it comes down to. But in any case, when you go to these schools and you pick up a science textbook, let's say an astronomy textbook, you're going to get a combination of things. You're going to get some good science in there, no doubt about that. You're going to learn about planets and their composition and so on. And you're also going to get a story, a secular story about how these things came about, how the worlds were created and so on. And it's a very anti-God story. A big bang exploded billions of years ago, and then accidentally planets sort of coalesced from the debris and so on and so forth. And then on one of these planets, chemicals just happened to come together and made the first life forms. It's all just an accident. Well, that's not the science, right? That's not evidence. That's a story. And the secularist strategy is very clever by mixing science, which we should respect because science, when it's done properly, it points to God. It reflects His character. But they've taken science, which is good, and they've merged it with their belief in evolution and secularism, their belief system, to try and get you to believe in their belief system. That's pretty clever, isn't it? And a lot of people have bought the lie, hook, line, and sinker. They've been baited in on the science, which is good, and they've swallowed the story, which is not really good science at all. And that's the topic I want to address tonight, particularly in the realm of astronomy, which is my specialty field. Because you see, astronomy really reveals creation. And we're going to see how the secrets of the cosmos confirm what the Bible teaches. That's my goal this evening. And we're going to look at 5 secrets of the cosmos that confirm biblical creation. We're going to see that the universe reveals God's glory as the Bible teaches, so the Bible certainly got that right. We're going to see that the Bible is right when it speaks to the basics of astronomy. Did you know the Bible does have some astronomy in it? That's not its primary purpose, but when it touches on astronomy, God gets it exactly right, as of course He would have to since He's God. And so when He touches on the basics of astronomy, things you would learn in any freshman level astronomy class, God got it exactly right. We're going to see that the Bible is right when it touches on the age of the universe. And of course the secularists have a very different age for the universe than what the Bible teaches, but we're going to see the science lines up with what the Bible teaches. It really does. We're going to see the Bible is right about the uniqueness of the earth. Earth is not just another planet out there. I mean, it is a planet, but it's not the sort of run-of-the-mill planet that secularists would like to believe. Earth is very special in God's eyes. And then finally, the Bible is right about starlight, and we're going to talk about how God got the light from those galaxies to Earth in the biblical timescale. So we're going to start with the glory of God being revealed in the universe. That's one of the purposes that God had in mind when He created this vast universe. It was designed to declare His glory, and the implication is to us. So we're to look, when we look out in the night sky, we see God's glory revealed. That's something we'd expect based on Psalm 19:1. The heavens declare the glory of God. The skies proclaim the work of His hands. And I think there are many different ways in which the universe declares God's glory, but I'm just going to focus on 2 this evening. We're going to see how the size of the universe declares God's glory, and the beauty of the universe declares God's glory. The size of the universe is immense and incomprehensible, but I'll at least give you some sort of feel for it so you have just at least a smidgen of the experience. And then the beauty, well, you don't have to be a PhD in astrophysics to appreciate the beauty of the universe. It really is stunning. In fact, you can go outside on a clear night if you get away from the light pollution, and it's really stunning to see what the Lord has created. And as we have, with technology, explored these issues even further with things like the Hubble Space Telescope, we've revealed a level of design that our ancestors probably couldn't have imagined. So it's really hard to get a feel for the size of the universe, but let's start with the moon. Now, the moon was one of the smallest things we're going to look at. The moon's about the size of the United States. If you were to put the United States up at the same distance as the moon, it would cover about the same area, roughly. And the moon has its own beauty to it. It's kind of a desolate beauty, but it is beautiful. It's fun to look at in a telescope. This is actually a mosaic image of the moon taken with a high-resolution spacecraft that's orbiting the moon. And of course, when we look at the moon with telescope, it's fun to see people's reaction as they look at it. It's wow, it's magnificent. And sometimes people will say, well, can you see the flag, that the astronauts planted? And no. When you consider that's the size of the United States, you're not going to see something that small on its surface. But thanks to spacecraft that are orbiting the moon and taking high-resolution pictures, we can actually see the places where the astronauts landed. And I want to show you one of these. This is absolutely amazing that we can do this. But in Mare Tranquillitatis, which is where the first Apollo landing was, as we zoom in and get increasing resolution, you can actually see the little bit of the lunar lander there that was left. Remember when they launched, they left the lower portion of the lander, like that spider-like looking structure, right, with the legs and so on, to save fuel. They just left the top portion. And so you can see the bottom portion, it's still there. And those little dark streaks that go off to the right and then come back, those are the footprints of the astronauts as they walked along the surface there over that crater. So 40-year-old footprints, and they're not going to go anywhere because there's no weather on the moon, so they'll be there for quite some time. And there's no maid service, so nobody's going to come and sweep up the footprints either. So that's the way it's going to remain. So isn't that amazing? We can actually see that. And of course, we can see that at the other Apollo landing sites as well. And so for those of you that think that we never landed on the moon because you read something on the internet, well, don't worry about it. Well, the scale of the cosmos is as amazing as its beauty. So again, we'll start with the moon, and it looks fantastic when it's in that first quarter phase, when it's illuminated right down the middle. You can really see the craters there very well in a small telescope. That's my favorite phase to look at the moon. It looks so three-dimensional. Your brain is able to figure out from the shadows of the craters that you're looking at a sphere. It's really neat. When the moon's full, you can't tell. It looks flat as a dime. But when it's in that first quarter phase, you can tell it's spherical. Here's the moon compared to the Earth at their true scale. And so it just kind of gives you a feel for the things that we're going to see in the universe. Now, the Earth, it may seem pretty big, but it's small compared to, for example, Saturn. Saturn is about 9 Earths across. That's just the planet. The rings extend even further out. The rings are trillions of tiny little moons that orbit Saturn's equator. And wow. And of course, astronomy is really a lesson in perspective, because when you see Saturn in a telescope, it looks tiny. I mean, you can see the rings, it's beautiful, but it looks like this tiny little gem that you just want to grab it and stick it in your pocket and take it home with you. But you can't, because it's 9 times the size of the Earth. Saturn's small potatoes compared to the sun. The sun is about 100 Earths across. And so at this scale, you can just barely see the Earth at this point. The sun is basically a stable hydrogen bomb. It's powered by nuclear fusion of hydrogen in the core, and that's a very efficient power source. God really knew what he was doing when he made the sun. And of course, he placed the Earth at the right distance to receive the proper amounts of heat and light. And Isaac Newton argued that doesn't happen by chance. That's the result of the mind of God. The sun is actually a star. And maybe you know that, because you would say, well, that's common knowledge these days. But to the ancients, that was kind of amazing to think that those little pinpricks of light that you see out in the night sky are the same type of thing as the sun. It's just the sun is much closer than these other stars. The sun is what we call a main sequence star. And basically that main sequence star is a star that obeys a rule that if you know the mass of the star, you know everything else about it. You know its size, you know its color, you know its temperature, its luminosity, everything is determined just by the mass. And the sun obeys that rule, and most stars do, but there's a fraction that don't, and those are the giants and supergiants. But if you get red main sequence stars, they're a little smaller than the sun. Color means temperature, by the way. So the sun's kind of a medium temperature star, about 6,000 degrees at the surface. And then red dwarfs might drop down to 4,000, a chilly 4,000 degrees at the surface. And then the blue stars can get up to 20,000 degrees at the surface in Celsius or Kelvin. Now, some stars are quite bigger than the sun. Mintaka, for example, which is a blue supergiant, it's one of the stars of Orion's belt that you can see in the winter sky. And you can tell it's blue. You can see its blueness to the naked eye, and that tells you it's very bright. The brightest, hottest stars are blue stars. But there are stars that are even bigger than Mintaka. So again, the sun's 100 Earths across, and it's now basically invisible. We go even bigger stars like Canopus, which is visible in the low south in February. There's stars even bigger than Canopus, like, for example, Antares, which is over 600 suns across. And, of course, the sun is 100 Earths across, so you multiply that out, and it's really, really big. Yeah. And, of course, there are stars, that's about the maximum. Stars maybe up to twice that big, and then there's a limit on how big you can make a star for physics reasons I won't go into. Some stars are kind of single, like the sun. Some come in binary pairs, and others come in these amazing clusters, like, for example, this M80, which is a globular star cluster. There are two types of clusters: open clusters, which have a few thousand stars, and then these globular clusters, which have perhaps 100,000 stars each. And there are several hundred of these globular clusters that belong to our galaxy and orbit sort of around its nucleus. And that's just one of them. Isn't that amazing? We can't even count the number of stars that we can estimate it at about 100,000. And it reminds me of that verse that says that God calls them all by their names. God has a name for each and every star, not just in that cluster, but in all clusters. Astonishing. Some of my favorite objects in the universe are not stars at all, but nebulae. A nebula is cloud. It's Latin for cloud, but it's not a cloud like in Earth's sky, which would be made of water vapor. These clouds are made of hydrogen and helium gas, which is the same stuff that stars are made of. But whereas stars are hydrogen and helium compact into a relatively small sphere, a nebula is hydrogen gas spread out over a vast region of space. And if there are stars nearby, they'll cause that gas to glow, and you get some very vivid and beautiful colors in these nebulae. It's quite stunning. They're a lot of fun to look at. And of course, my point here is that our solar system really would not show up on this image. We're at such a large scale now. And that's one of the larger nebulae. Now, not all nebulae are large. Some are small, and these small ones are called planetary nebulae. And that's an example of a planetary nebula. In that case, with a planetary nebula, you have a star in the middle, and it's ejecting gas out the poles, out the north and south pole, and so you have a bipolar structure there. They call that a bipolar planetary nebula. And some planetary nebulae are round, but they all have a star in the middle, either one that's still active or one that's collapsed in on itself and become a white dwarf. And here's one of my favorites. This is the Ring Nebula. One of my favorites because it's the first that I got to see with my own eyes. And that was very exciting for me when I was quite young and was pointing my telescope out. And of course, it takes a little bit of practice to learn how to do that. But then you can find this little guy not too far away from the star Vega, a wonderful object in our summer night sky. So weird, because most places you point a telescope, you just see stars and stars and stars. And they're beautiful, but they're just stars. There's this one little magic spot where you will see a glowing smoke ring. And it is so strange to see this smoke ring just hanging there. You're expecting it to expand like you've seen smoke rings do on Earth. And of course it is expanding. It's just so big that we don't notice it in a human lifetime. But yeah, there's one little spot where you will find this little cosmic Cheerio suspended on nothing. Really rather remarkable. Now, all these things that we've looked at, all of these stars and nebulae and star clusters and so on, are in a much larger object called a galaxy. So we're in one of these galaxies, and for a long time, astronomers thought that our galaxy was the entire universe. But we now know that our galaxy is one of many. This is an example of a galaxy that's not too far away from ours. This is called the Whirlpool Galaxy, and you can see this in a small telescope, and it's quite spectacular. And if you get to really dark skies with a decent telescope, you can see those spiral arms there. If you have just a mediocre telescope, you'll see just the two bright cores, that one right there and that one right there. It looks like two galaxies that are in the process of collision. So really rather remarkable. But yeah, now we know that our galaxy is one of maybe 100 billion in the visible universe. And each one of these galaxies has perhaps 100 billion stars in it, so many that you can't see any of the individual stars. You have to zoom in on it to see those. There are all kinds of galaxies in the universe. There are galaxies of tremendous beauty. There are galaxies of tremendous ugliness. Yeah. There are galaxies that have large, mysterious arrows next to them. You'll see that in all the textbooks, always pointing to something interesting, too. There are galaxies that have rings of stars surrounding them. Isn't that interesting? There are galaxies that look like flying saucers. That is a real galaxy. That's the Sombrero Galaxy. You can see why they call it that. And it's part of the Virgo supercluster, which is a cluster of galaxies, about 2,000 galaxies, relatively close to ours. And you can see that in a small telescope if you know right where to look. And I got a book on this that I'll tell you about later that I'll show you if you want to learn how to find these things. It's a lot of fun. And you can see that dark dust lane there that blocks the light from the stars behind it. There are galaxies that are in the process of collision. Of course, the stars would all just pass by each other. It's not a problem because the distance between stars is enormous compared to the size of stars. So to suppose that any two stars would collide, it'd be like me throwing a sand grain at you and you throwing a sand grain at me and expecting them to collide. It's possible, but it's not very likely at all. We now know that galaxies come in clusters. Here is a particular cluster of galaxies. Those are not stars that you're seeing. They're not individual stars. But each one of these little fuzzy spots is a collection of about 100 billion stars. Some less, some more. Amazing. As we go out even deeper into space, we see galaxy upon galaxy. That's not a star field. That's a galaxy field. Each one of those little specks, no matter how tiny they are, is a galaxy at distances that you can't imagine the distances that these things exist at. Truly remarkable. All made, all spoken into existence by God. He spoke, they leapt into existence. That's awesome. That's power. Think about the power that just our own sun puts out. Our sun puts out more energy in 1 second than 1 billion major cities could use in a year. That's one star. And there's 100 billion stars in our galaxy. And there's at least 100 billion galaxies. That's awesome. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars. Each, it's summed up in this little phrase, He made the stars also. Yeah. It was just so easy for God to speak those into existence. And of course it was from His perspective because He's God and His power is unlimited. Really remarkable. Certainly the universe declares God's glory. It's not what we'd expect if it was just a chance random explosion. It's got beauty in it. It's got design in it. It's got God's glory built into it. What about the basics of astronomy? Stuff that you would learn in any freshman level astronomy class. Well, the Bible got that right too. Now the interesting thing is some of these things that they will teach in a freshman level astronomy class are things that in the past secular experts would have said, no, the Bible's wrong. And yet today we would have to agree the Bible got it right. Let me show you some examples of these. The spherical nature of the earth. You know, some people have said, oh, you believe in creation, that's like believing in a flat earth. Well, they haven't read their Bible because the Bible talks about the world being round, spherical, circular. The circle of the earth is mentioned in Isaiah 40:22. And you might think, well, that could be just a circular disc. It wouldn't have to be round. But I think the passage in Job, there's no way to interpret it any other way than that the world really is spherical. Because the passage there says that God inscribes a circle on the face of the waters at the boundary between light and darkness. And that boundary is what astronomers call the terminator. That's where light stops or terminates. And it's always a circle. And the only way that can be is if you're on a spherical world, especially with the water. It's always on the waters there because the Earth's surface is mostly water. Now, the interesting thing I've found is that most astronomy textbooks will credit Pythagoras with being the first person to come up with the idea that the Earth might be round. Aristotle is considered the first to prove that the world is round from shadows of eclipses and the fact that you can see the top part of the boat before you can see the bottom part of the boat when they're coming into shore and so on. But, that's Pythagoras is 500 BC, Aristotle's 300 BC. As far as I can tell, the Bible is discussing the spherical nature of the earth long before the secular experts of the day figured it out. Isn't that interesting? It's almost as if the Hebrews had some kind of divine insight into this issue. And of course, that doesn't surprise us, those of us who are Christians and take the Bible at its face value. By the way, the idea that Christopher Columbus was the first to prove that the world is round is a myth. Educated people already knew the world was round at the time of Columbus. He just thought it'd be faster to go that way, which it turns out it's not. So anyway, I'm glad he did, though. I'm glad he made the trip. Anyway, Earth is suspended in space is something that the Bible teaches, that God hangs the earth upon nothing, a beautiful poetic description of the nature of gravity. What better way to say it than God hangs the earth on nothing? And of course, that we know that today. We've got pictures of the earth from space. We understand that. But it might have been hard to believe when it was written in 2000 BC. Even as late as 800 to 900 BC, the early Greeks were teaching that the earth was a flat disk that floated in water. And doesn't that make a lot more sense? I mean, we've seen things float in water, but have you ever seen something being hanged on nothing? That can't happen. I wonder if it was tempting for any of the Jews at that time to say, well, yes, I know the Bible teaches that God hangs the earth on nothing, but the best experts say it's a flat disk and floats in water. So maybe we need to reinterpret these passages. I don't know if that happened, but if they did believe that, they've got an egg on their face today, because the Bible was exactly right. God knew what he was talking about. The earth indeed is suspended in space. The expansion of the universe is something that I believe the Bible teaches. It says in a number of places, including Isaiah 40:22, that God stretches out the heavens as a curtain and spreads them out as a tent to dwell in, indicating that the universe has gotten bigger since the Lord first created it. He's stretched it out. And that, in fact, is something that we would now agree upon. It must have been hard to believe when it was written, though. And frankly, if you don't know much about astronomy, it might be hard to believe today. You go outside tonight and look at the night sky. It looks about the same size as it did last night, right? It's hard to believe it's being stretched out or expanded, but in fact it is. And what happened was in the 1920s, secular astronomers came along and confirmed that. Hubble and others were measuring redshifts of galaxies, which indicates sort of the way they're moving away from us. And they found that all galaxies sort of are moving away from all other galaxies, some exceptions that are very close. But generally, the universe is being stretched out or expanded, almost as if it were a tent being stretched out or expanded. How about that? And that's, of course, exactly what the Bible teaches. It's just the Bible got it right thousands of years earlier. It wasn't really until the 1920s that they figured it out. Up until the 1500s or so, most astronomers believed the universe was static and eternal, and therefore it couldn't be stretched out. And so this was really challenging to them. But the Bible's vindicated. The universe is apparently being stretched out like a curtain. Now, some people have said, well, does this mean that there was a Big Bang, right? Because if everything's expanding out like that, didn't the Big Bang predict that? Didn't the Big Bang predict that we should see evidence of expansion? The universe exploded into existence, and so everything ought to be moving away. Well, the answer is no. The Big Bang did not predict this. This effect of expansion was discovered in the late 1920s. The Big Bang idea, the idea that the universe came from a point that then, sort of expanded thereafter, is 1931. The guy who came up with the Big Bang already knew about the observational evidence of an expanding universe. And it wasn't until 1931 that it occurred to him that maybe we can run it all the way back to a point. But there's no reason to run it all the way back to a point, you see. But some people have said, well, does it at least count as evidence for the Big Bang, even if the Big Bang was invented after the fact to explain it? I mean, if everything's moving away from each other like that, doesn't that mean the universe exploded into existence 13.8 billion years ago? And the answer is no. Just because something's expanding doesn't mean it exploded into existence 13.8 billion years ago. Some of you are expanding a bit. That doesn't mean you exploded into existence 13.8 billion years ago. Not at all. It just means you're a little bigger now than you were some time ago. As far as I can tell, God made the universe with size, and he stretched it out a bit since creation. He doesn't tell us how much. There's no reason to think it came from a point just because it's getting bigger. That doesn't follow logically. Now, the next one I think is a little harder to, it's a little more abstract, but I do believe the Bible teaches a principle called conservation of energy and mass. That is, the amount of stuff in the universe is constant, the amount of energy or mass. Einstein tells us energy and mass are basically the same thing measured in two different ways. We'd expect this on the basis of Scripture because the Bible indicates that all things were made by him, that is by God, by Christ in particular. And on the seventh day, God ended his work of creation. And so what that means is new stuff is not going to just pop into existence, because either it would mean that God is still creating, which cannot be because he ended his work by the seventh day, or it would mean that stuff can come into existence apart from God, which cannot be because all things were made by him. So no new stuff's going to pop into existence. Furthermore, we would expect that stuff would not simply fade away and cease to exist, because God upholds all things by the word of his power, and in him or by him all things consist or hold together. So God maintains the existence of that which he created. Now he allows it to change. We can transform energy into different forms, but the amount of energy is constant. We'd expect that on the basis of Scripture. It's hard to pin down when secular scientists came to accept the idea of conservation of energy, but it's usually credited to James Joule. And from what I can tell, he was motivated by the Scriptures to believe that energy was conserved, and he found that in his experiments, indeed it is. But he's 1800s. And so again, the Bible got this right long before secular scientists came to agree with what the Bible teaches. I should add too, because some people say, well, does this mean that God can't do a miracle where he creates new stuff? Well, of course not. God can do what he wants. He's God. This is a general trend, okay? This is the general trend that we would expect to see. God can make an exception if he wants to. Uncountable stars. Abraham's descendants are described in the Bible as the stars of heaven and as the sand which is upon the seashore, a metaphor indicating a humanly uncountable number. In fact, in Hebrews it's mentioned that way. It says, which cannot be numbered for multitude, indicating by human beings. What a great analogy for an uncountable number, the stars of heaven, the sand which is upon the seashore. Of course, it might not have seemed like such a great analogy when it was first written, because the number of stars you can see with your naked eyes is a few thousand, 3,000, maybe 10,000 if you got really superb vision and you stay up all night and count all of them. But that's a big number, but it's countable. You could count to 10,000. It would be tedious, but you could do it. But then telescopes were invented in 1608, and by 1610, Galileo had made his own good one, and he started looking into the heavens, and that Milky Way that looks like a cloud in the night sky, that's actually hundreds of billions of stars. And there's no way you can count 100 billion stars. You could not do that in your lifetime. And so you see the number of stars just in our galaxy is humanly uncountable, and we now know that our galaxy is one of hundreds of billions of others. This is a great analogy. As a side note, there was I should tell you that even just a few hundred years ago, many astronomers believed that the number of stars in the universe was exactly 1,022. And you'd say, why would they believe that? Well, because the Greek astronomer Ptolemy had cataloged 1,022 stars. And although he never even claimed that his list was exhaustive, he certainly didn't intend it to be that way, there was a philosophy at the time that everything worth knowing had been discovered by the Greeks. And so if Ptolemy hadn't cataloged it, it wasn't there, despite the fact you can see more stars than that. It really is an example of how an incorrect philosophy can interfere with your understanding of the evidence, seeing something that's right before your eyes. So here's my question. Do you get the point? Have you learned the lesson of history? That's what I want to know. In the past, whenever the experts of the day have disagreed with the Bible has always turned out to be right. What about today? Have we learned that lesson of history? Have we learned that God's word is right, even if we don't understand all the evidence? God knows what he's talking about. Well, some people have learned that lesson, many haven't. And there are people today who say, but the Bible got this wrong, the age of the universe. We know that. We know the universe is billions of years old. The Bible indicates a much shorter age. But what I want to show you this evening is that the Bible got that right too. The evidence actually lines up with what the Bible says. The Bible's right about the age of the universe. Many lines of evidence confirm a universe that's thousands of years old. Does the Bible really teach a young universe? Well, it certainly does. It tells us that God created in 6 days. It's clear from context those are ordinary, approximately 24-hour days, because each one is defined in terms of an earth rotation. There was an evening and a morning, the first day, evening and morning, the second day, and so on. The universe beyond Earth was made on day 4. That would include the planets, the stars, the sun, and the moon. And that was we know that was a few thousand years ago because human beings are made on day 6, and from adding up those genealogies, we find it was something like 6,000 years ago. Can't put an exact date on it, but it would be something like that. Certainly wouldn't be millions or billions of years. And boy, that's something that secularists really hate. They don't want you to believe in 6,000 years because once you give up the billions of years, evolution doesn't have a chance. That's the primary motivation for believing in evolution. It's not because of scientific evidence. It's because of a philosophy of naturalism. You got to produce life without God because people don't want to believe in at least the biblical God. They want to make up a God they can control. And as a result, you need evolution. And to get evolution, you need billions of years because we all know it can't happen in a short period of time because we don't see it. That's really the motivation for this. But I want to show you that there's evidence that confirms the biblical time scale of thousands of years. And there's quite a lot of it. Jupiter, for example, Jupiter emits twice as much energy as it receives from the sun. Okay, so it's getting 1 unit, giving away 2, right? Takes 1 in, spins away 2. Or whatever it gets, it gives away twice as much, kind of like our federal government, right? Spending away twice as much as it takes in. And like the federal government, it can't do that forever because eventually it runs out of energy, yes? Now, Jupiter's a big planet, and it can do that for a while because it has a lot of internal energy to begin with. It's kind of like a potato that you take out of the microwave. It's nice and warm. You've just heated it up. You can feel the heat coming off of it, right? You can feel that. But it doesn't stay that way forever, does it? It radiates that heat into space, and after a while, it's cold. Now, Jupiter can do it for a lot longer because it's a much bigger potato, and so it can do that for a few thousand years. It's not a problem. But if it were billions of years old, why does it still have all that internal energy? It is a problem in the secular view. The problem is even worse for Neptune, which gives off 2.6 to 2.7 times as much energy as it receives from the sun. And it's a smaller planet, so it can't hold as much energy to begin with. So there's no way these worlds can be anywhere near billions of years old. By the way, that's true of a lot of planets. Earth even gives off more energy than it receives. But at least with Earth, they would say, well, radioactive decay might be able to produce new heat. But with Jupiter, it's made of the light stuff, so it's not going to have radioactive elements in it, at least not in any sufficient quantities to heat it up. Magnetic fields are an indication of youth. The Earth has a magnetic field that's generated by electrical current in its core, and it interacts with solar radiation. The solar radiation is actually deflected by the Earth's magnetic field. It protects us like an invisible shield. It's a design feature. But that magnetic field, which is generated by electrical current, well, electrical current encounters resistance and it runs down. And so Earth's magnetic field has been decaying since creation. And we've actually been able to measure that for the last almost 2 centuries. And by the way, we think that during the flood year, the Earth's magnetic field rapidly reversed due to the rapid movements of plate tectonics. That's a complication I don't want to go into. But the point is, the magnetic field, other than that, the magnetic field has simply been decaying. And it would have been maybe 20 times stronger at creation, which would have been nice. We'd have increased protection from cosmic rays, which would give us increased protection from things like cancer and so on. But in any case, it's decaying. And you run it backwards. It's an exponential decay as far as we can tell. And you run it backwards, and you find that the Earth's magnetic field can't be more than about 60,000 years old maximum. If it's that large, it would be stronger than a neutron star, and you don't want that. That would rip the atoms of your body apart. So it can't even be 1 million years old, let alone billions. Earth's magnetic field is very consistent with the biblical timescale. In fact, that's true of not just Earth, but a lot of the planets. Jupiter has a whopping big magnetic field. It would be larger than the sun if you could see it. And why does it have that strong magnetic field if it's billions of years old? Magnetic fields run down with time. They decay. Batteries run out. Why does Jupiter still have all this electricity in its battery? Well, I want to suggest to you it's because it's thousands of years old and not anywhere near millions or billions. Likewise, the planets Uranus and Neptune, which are almost twins, they're very similar planets. The planet Uranus actually rotates on its side like that, so it rolls around the sun, and it's got a magnetic field, a magnetic axis that's not aligned with the rotation axis. It's kind of shot through the side there. It doesn't even go quite through the middle. Really interesting. So the planet Uranus is just really messed up on a number of levels, and I think God did it that way just to confuse the secularists, because there is no secular explanation for why it's this way. They want to try to, well, maybe something collided with it, but that really doesn't account for the magnetic field axis. Anyway, a friend of mine, Dr. Russ Humphreys, who is a PhD physicist, and he's a biblical creationist like myself, he's actually able to predict the magnetic field of the planet Uranus based on its biblical age of 6,000 years. And when Voyager 2 flew past Uranus, Dr. Humphreys was right on. You see how real science starts from the Bible if you want to get the right answer? The secularists' predictions were way off, because they figured Uranus is billions of years old. The magnetic field should have run down by now. It should be essentially zero, but it's not. Dr. Humphreys was right. The same is true of Neptune. In fact, Dr. Humphreys' model actually accounts for the magnetic field of all of the planets. It's just interesting because he was able to, we already knew the magnetic field of the planets up to Saturn, and he was able to predict it for the 2 remaining planets, Uranus and Neptune, and he was right on. Right on. The secularists were way off. They have to try and get the magnetic field to recharge itself. If you've ever heard of a dynamo model, that the idea there is it's kind of like the alternator in your car. It takes mechanical energy and turns it into, kind of recharges the battery. But the alternator in your car is kind of a sophisticated mechanism. And as far as we can tell, planets don't have things like that. As far as we can tell, the magnetic field is simply decaying, and it's consistent with what we find on all of the planets today. The moon is actually moving away from the Earth due to tidal forces. You might know the moon causes tides. It pulls on Earth's oceans, and Earth rotates faster than the moon orbits, and so the tidal bulges always get a little bit ahead of the moon, and they pull forward on it. And when you pull forward on something in orbit, it moves out. It's a little counterintuitive, I know, but that's the way it works. If the astronauts want to go into a higher orbit, they thrust forward, and that puts them into a higher orbit. It's gaining energy. You see, the moon's stealing a little bit of Earth's rotational energy, moving it away. It's about 1.5 inches a year. So you don't have to worry about the moon leaving anytime soon, okay? It's a small amount, because it's 240,000 miles away. So what's 1.5 inches a year among friends, right? But if you run the equation backwards, and you have to do it properly because when the moon gets closer, the tidal bulges get bigger and it goes faster, so you have to compensate for that. You find that 6,000 years ago, the moon would have been about 730 feet closer to the Earth. Not a big deal at all. But if you run it back 1.4 billion years, the Earth and the moon would have been in the same place at the same time. And that can't happen, you see. And you say, well, that sounds like a lot. I mean, 1.4 billion years. But here's the point. Secularists believe the Earth-Moon system to be 4.5 billion years old, right? And last I checked, 4.5 billion is bigger than 1.4 billion, right? Even the Common Core folks understand that one, right? Yeah. Okay. So you see, that's a problem. That's a problem for the secular view. Comets. Comets are made up of icy material that orbits around the sun. They're kind of they're just a few miles of ice. But then as they get close to see, they kind of go far out and then they get whiplashed around like that. They come close to the sun and get whiplashed back out. Now, when they come close to the sun, that icy material is vaporized and blasted away into space, and that's what forms a comet's tail. That's material that's actually being depleted by solar wind and radiation. So every time you see a comet, it's getting smaller. And we know how much material's there, and we can see the rate at which it's depleted, and so we can calculate that a typical comet, can't last more than about 100,000 years maximum before it totally runs out of material. Now, if the solar system is 4.5 billion years old, then why do we still have comets? That's what I want to know. That's a problem, isn't it? I know comets don't last long. I used the SOHO spacecraft in my doctoral research, and it's designed to look right at the sun. And sometimes comets will pass behind the sun, and then you don't see them anymore. They're totally obliterated in one pass. I've seen that happen. I've seen comets that no longer exist because they were destroyed by the sun. They don't last millions of years. Now, if the solar system's a few thousand years old, of course we can still have comets. But if it's billions of years old, they would be gone. And my secular colleagues have said, well, obviously there must be a comet generator that makes new ones, right? Which they call, that's what they believe. They call that the Oort cloud. And the idea is it's beyond, there's this big cloud of orbiting potential comets out beyond the farthest planets, too far away to be detected. And every now and then, one of these potential comets is kicked into the inner solar system and becomes a brand new comet. So as old comets disintegrate, new ones replace them. Isn't that convenient? But as far as I can tell, there's no evidence of an Oort cloud. You'll find it in the textbooks. That's the only place you'll find it. You won't find it in the actual universe. Spiral galaxies are an indication of the youth of our universe. Spiral galaxies rotate differentially, which means the inner portions rotate faster than the outer portions in terms of their angular velocity. And so a star here will make a lap in less time than a star out here. And if you think about what that does, it's going to cause that spiral structure to twist tighter and tighter and tighter. I actually ran some computer simulations to find how long does it take for that spiral to get twisted beyond recognition. And the answer is it doesn't take more than about 100 million years, and it's gone. But you see, these galaxies in the secular view are supposed to be 10 billion years old. You see, they can't be anywhere close to that because the spiral structure would be gone. It would be twisted beyond recognition. You might notice that these spiral arms have kind of a bluish tinge to them. That's because they have a higher proportion of blue stars than the inner portions of the galaxy, the nuclear bulge. And blue stars are themselves an indication of recent creation because blue stars are the hottest, most luminous stars in the galaxy, and they expend their fuel quickly, and therefore they cannot last billions of years. They would have exhausted their fuel a long time ago. Now, as it happens, they tend to be the most massive stars, so they have the most fuel available, but they use it up at an incredible rate. They're kind of like the SUV of the star world. They got a big gas tank, but they get very poor gas mileage, and so they can't really go very far in time. And by the way, my secular colleagues, they won't even dispute this one. They know that blue stars are young. They know that. But again, they say, well, obviously there must be some process that makes new ones. But it's really tricky to make a star. As far as I can tell, it's something that only God can do. Now, I won't be dogmatic on that. A star is not complicated in terms of its structure like an organism, right, where it requires design. A star is a ball of gas. That being said, gas doesn't want to just collapse in on itself into a little ball. Gas tends to spread out into the volume of its container. And when you walked into this room, you didn't hold your breath just in case all the air should come over here and form a little ball. You assumed it would spread out. That's what gas normally does. Normally, now, by the way, once you get the gas into a ball, something the size of a star, its own gravity will hold it together. But getting it there is a huge problem because normally in space, the outward gas pressure is much greater than the minuscule inward force of gravity. And then there are other problems too in terms of getting the magnetic field, which tends to repel and dumping angular momentum and so on. I'm not convinced that stars can form. And you've said, oh, but, Dr. Lisle, I've seen in textbooks, they say this is a star-forming region. Let me clue you in. They don't see stars forming there. What they see are blue stars. And they say, well, stars must have formed recently, right? Because we know the universe is billions of years old. And here are all these hot blue stars that can't last that long. This must be a star-forming region because you find all these young stars there. But they don't actually see stars forming. No one's seen a star form. I think it may be impossible. And again, I won't be dogmatic on that. So you see, the evidence really is very consistent with the age of the universe that the Bible indicates. What about the uniqueness of Earth? The Bible teaches that Earth is not just another planet. It's very special in God's eyes. Now, it might be not particularly spectacular in terms of size and some of its other properties, but it is the place where God put the people that he made in his own image. And that's pretty awesome. Isaiah 45:18. He's the God who formed the earth and made it. He established it and did not create it, a waste place, but formed it to be inhabited. The earth is designed for life. And to show its special significance, God actually created it 3 days before anything else. God makes the earth on day 1, if you read Genesis chapter 1. All the other objects in the universe are made on day 4. The sun, moon, the stars also. The Hebrew words for star, kokab, would include planets other than Earth. The earth really is special. The other worlds of our solar system, they have their beauty, don't get me wrong. One of the astronauts who walked on the surface of the moon called it a magnificent desolation. I think that's a great description of it. But it's not designed for life. What about the other planets? Venus, a little closer to the sun. Mars, a little further away. Beautiful, not designed for life. Venus, the surface temperature there, 900 degrees Fahrenheit. Not going to want to visit there on your next vacation. And it's always enshrouded in clouds, and you might think, well, that would help a little bit. Nope, because those clouds are sulfuric acid type compounds. Lots of ways to die on Venus. Not a place you want to visit. Mars is a little better, but even there, its current atmosphere wouldn't support you. You couldn't breathe on Mars because it has a very thin atmosphere of carbon dioxide, which you can't breathe. So that's not going to help you either. They're not designed for life, not like the Earth is. Kind of like Goldilocks and Three Bears, right? You got those ones, too hot, that one too cold. Earth's just right. That's what we'd expect, given what the Bible teaches. It really is a very special planet. What about distant starlight? I'm going to have to go through this kind of quickly. The Bible's right about this as well. Distant starlight's not a problem for a young universe. And let me clue you in on here a little bit if you haven't heard this. It's an argument that secularists try to use to discredit the Bible. They'll say, well, you have these light from these distant galaxies, and they're very far away. And I agree, they're very far away. And given that even though speed of light's very fast, these things are so far away, you would think it would take billions of years for the light to get from there to here. And we see these galaxies, so obviously the light has gone from there to here, right? And so the universe has got to be billions of years old, right? Well, it turns out that there's an answer to this, and I do have to point out that there are some answers that people have proposed that are not reasonable. And I don't have time to go into this in detail. I have another DVD on this if you're interested. But the distances are not real. I think they are real. There's good science for that. Or the speed of light was much faster in the past. I think that was a great thing to try, but there are good reasons to believe the speed of light has always been what it is today. Or the light was created in transit. A lot of people have said, well, God made Adam as an adult. He made the earth as an adult, right? And that's true. Maybe he made the stars and he made the beam also. And I kind of like that, but there's a problem with it. I think that works on most other things, but I don't think it'll work for starlight because light in transit requires God to create fictional images and movies, right? We saw a star, for example, explode in 1987. That star that you see there blew itself to bits, and it's in one of the Magellanic Clouds. Today, you just see what's left of it, just kind of a remnant. But that thing is way beyond 6,000 light years away, which means if you think, well, the way God got the light here is he made a beam with the light already in it, then it means that star never existed. It was just a picture that God put in a beam of light about 6,000 light years out, and then he made a picture of that explosion, like a little movie along a light beam. where none of the objects actually existed. And of course, I don't deny that God has the power to do that. I just think it's inconsistent with his nature. God's not the author of deception or anything like that. So I think we have, in any case, I think we have a better answer than that. Some have pointed out that time dilation might solve the distant starlight problem. I think there's potential there, but I haven't seen a version of that mathematically actually works. I'm going to give you what I think the answer is. I don't claim to be dogmatic. The only thing I will be dogmatic about is that God's word is true, and he tells us he made in 6 days, and that settles that issue. But I think we have a good model as to how God may have done that. The solution may involve what we call the one-way speed of light. The speed of light is very fast. It travels 186,282 miles per second, but that is a round-trip average speed. Let me show you what I mean by that. Suppose we wanted to measure the speed of light. Okay, so what I'm going to do is I'm going to stand over here with a flashlight, and we're going to build a long hallway, 186,282 miles long. We'll pretend we have government funding. We can waste it that way. And we'll put a mirror at the other end of the hallway, or maybe I've got a friend over there with a flashlight. Either way, it doesn't matter. And when my clock hits noon, I'll turn on the light pulse. It goes out, bounces off the mirror, and comes back. And as soon as I see the reflection, I'll look at the clock and see what the time is. Now, it turns out that if I did this experiment, the light has to travel 186,282 miles and then back that same distance. It would take 2 seconds for the light to do that. And so I would calculate, and I would say, well, 186,282 times 2 divided by 2, that's the speed of light. 186,000 miles per second is the speed of light. Now, most people assume that it took 1 second to go out and 1 second to come back, because I've pictured it that way. But if you think about it, I don't really know that. I'm here with my flashlight. I know when I start the experiment, and I know when I see the reflection, but I don't know when it hit the mirror. It might be the case that it zipped out, took no time at all to go out to the mirror, and then took all 2 seconds to come back. That could be the case. Or it could be the case that the light took all of its 2 seconds to go out and then zipped back. You see, I'm standing here. I'm going to see the same thing either way, aren't I? You say, well, why would it be different in different directions? I don't know, but I don't know why it would have to be the same either. Science isn't about just, well, I'd like it to be the same in all directions, so there it is. It doesn't work that way, right? You have to test things in science. So how would we test to see if the light goes out the same direction as it comes back, or the same speed it comes back? And you can see if this is the case down here at the bottom, if light, when it's moving toward an observer, takes no time at all, then there is no distant starlight problem, right? Because the light doesn't have to go out to the galaxies and then come back. It only has to go from the galaxy to the Earth. And so I'm kind of hoping this bottom case turns out to be right. But wishing for something doesn't make it so. We need to test this. So how would you test the one-way speed of light? Well, you can't use a mirror anymore because we're not going to bounce. We've got to measure a one-way trip. So you're going to need another clock. You're going to need one clock to tell you when to start the experiment and another clock to tell you when to stop, when the light arrived, okay? And so here I am, and at noon I turn on my flashlight, and the other clock over there records the time. And you're thinking, yeah, it'll be 1 second past 12. Well, not necessarily. I did this experiment in my office. I don't have a long hallway, but I do have the distance between my watch and my phone. My phone has a clock on it, and I can convert. I'm pretty good at math. I can convert, okay? And so right at noon, I turned my flashlight on, right at noon, hit the phone, and I looked and saw when it hit the phone. I read the time, 12:05. Light takes 5 minutes to go from my watch to the phone. Do you believe that? You better not believe that, no. Now, I really did that, and that really is the result. But what went wrong? What assumption did I make? I assumed that the two clocks were synchronized. Obviously, the clock on my phone is 5 minutes fast, right? Really, it took virtually no time to get for the light to get from my watch to the phone. So you need synchronized clocks for this to work. And you say, no problem. We'll just make sure our clocks are synchronized. Turns out, it's impossible. When two clocks are separated by distance, it is impossible to synchronize them in a way that is objective, that everyone will agree upon. I'm already a little bit over time. I don't know how much I can get into this. I'll just point out the two ways that people try and synchronize clocks by distance. One is by radio transmission. You'd say, well, in fact, my watch will do this. My watch receives a radio transmission from Fort Collins, Colorado, which is connected to the atomic clock in Boulder. Pretty neat. It synchronizes itself at midnight or 1 o'clock or something. But technically, my watch is a little bit behind the atomic clock in Boulder because radio takes a little bit of time. Not much, but it takes a little bit of time to go from the transmitter to my watch, right? So synchronizing the two clocks by this method, it's not going to work because that one will be just a little bit behind the other one. Now you say, but if we knew how fast the radio travels, we could subtract that off, right? We could push it ahead a little bit. Do you know how fast radio travels? Radio travels at the speed of light. You see the problem? That's the very thing I'm trying to measure. So I'd have to already know the one-way speed of light in order to use radio or anything like that to synchronize two clocks separated by a distance. I won't go into all of these, but I will. The other one that people will try to point out is they'll say, well, maybe we can synchronize both clocks together and then move them to opposite ends of the hallway. Sounds great. You'd say, well, they're still synchronized, right? Wrong. Einstein says that motion affects the passage of time. The very act of moving the clocks causes them to become slightly desynchronized. Now, it's not a huge effect, but it's there. And even a small change can make an enormous error in our measurement of the one-way speed of light. You see the problem there? Now, perhaps all is not lost. There is an equation that tells you how much time the clock loses or gains as it moves. But you know, in that equation is the one-way speed of light. God has designed the universe to where we can't measure the one-way speed of light. Apparently, it's impossible to synchronize clocks separated by a distance without knowing the one-way speed of light. And it's impossible to ever measure the one-way speed of light without synchronized clocks. We are stuck in a permanent catch-22. And I think that's very interesting. And this is something that's been explored by physicists for about a century. They've been exploring this in literature. It's a very fascinating issue, the problem of distant simultaneity, they call it. And the fact that you can't objectively synchronize clocks separated by a distance. And so my conclusion is the one-way speed of light is, in fact, not a property of nature at all, but a convention, something that we get to pick, and we all stick to it, and it works. So without going into all the details, because I'm over time, you can think of it like this. I can define the speed of light, the one-way speed of light, however I like, within certain constraints, as long as the round-trip speed remains c. And so I can define the speed of light to be instantaneous when it's moving toward me, as long as it's half c when it's moving away. And that works. You can do that. You can do it other ways too, but that's a perfectly legitimate solution. It's kind of like time zones on the Earth. And so the way you get starlight here, I can leave Kentucky at 4 o'clock and arrive in California at 4 o'clock. And I've very nearly done that on some flights because of the way the time zones work, the way we define time, which is kind of arbitrary a little bit. I mean, we prefer to have the noon when the sun is high and so on. There are other ways you could do it. That's a human convention. As long as you're going west, it works. You can arrive when you leave. You can do the same type of thing in space. The light can leave a star on day 4 when the star is first created and arrive on Earth at day 4 because of the way time is measured in space, at least one way of measuring time in space. And I think the Bible uses this particular convention because in Genesis 1, 14 and 15, then God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years." We learn later that's the sun, the moon, the stars also. "And let them be for lights in the expanse of the heavens to give light on the earth." And it says, "And it was so." What was so? God made the lights, and they gave light on the earth, apparently. As soon as God created them, they immediately fulfilled their God-ordained purpose of giving light on the earth. They didn't need any time at all. And that is perfectly consistent with what we understand about physics. It's called the conventionality thesis. You might look it up. There are secularists who would agree with me that that is a legitimate solution to distant starlight. They don't like the fact that it does solve distant starlight, but they will agree that if they know anything about physics, they'll agree that that is a good solution. So, is that the way that do I know that's the way God did it? No, but it is certainly a reasonable way that he could have. And so there isn't a problem getting the light here in thousands of years. So, what have we seen? We've seen that the Bible's right when it speaks about the glory of God being revealed in creation, in the universe in particular. We've seen the Bible's right when it speaks to the basics of astronomy, things you'd learn in any freshman level astronomy class. The Bible's right when it speaks about the age of the universe. We've seen how the evidence lines up with the biblical timescale. We've seen that the Bible's right when it speaks to the uniqueness of the earth. And we've seen the Bible is right when it addresses distant starlight. And I've shown you one method that has yet to be refuted. I published this back in 2010 in a technical journal, and nobody's been able to refute it, so I think we got a good model there. But don't pin your faith on my model, pin your faith on the Word of God. That's really what it comes down to.